Hello, space enthusiasts and curious minds. Welcome back to our channel, where we dive deep into the latest cosmic discoveries. Today, we're uncovering a groundbreaking update from NASA regarding the James Webb Space Telescope's recent findings on Mercury. Strap in as we explore what this could mean for science and our understanding of the nearest planet to the Sun. For the first time, we've achieved orbit around Mercury, sparking a new era of cosmic exploration. After a long silence, NASA has unveiled striking new findings from the James Webb Space Telescope. These revelations, kept from the public until now, focus on Mercury, a planet whose blistering surface and volatile atmosphere have captivated and intrigued for decades, offering a unique glimpse into the extremes of planetary formation. The discoveries by JWST are revolutionary, confirming what many suspected, but none could prove. What the telescope has identified on Mercury's surface is stirring a storm of cosmic mysteries. This anomaly suggests the presence of advanced processes that could challenge our entire understanding of Mercury and reshape our concepts of the solar system. What has NASA unearthed on this scorched planet? Join us as we delve into the details of how NASA, using the James Webb Telescope, has brought these discoveries to light. Mercury, orbiting so close to the Sun, was assumed to be a barren, lifeless rock. Experts had long predicted that this small planet, only marginally larger than Earth's moon, would be geologically dead. Yet the latest data hint at a very different reality. Despite enduring the fierce onslaught of the Sun's powerful radiation, Mercury has emerged not as a barren wasteland, but as a planet of profound paradoxes and unexpected complexity. The stark temperature differential, which spans approximately 100 degrees Fahrenheit between its day and night sides, underscores the planet's extreme and inhospitable environment. Yet, intriguing data reveals that Mercury is far more than a mere arid rock. Visible to the naked eye, Mercury has been a fixture in the human gaze for millennia, known across ancient civilizations long before the advent of written records. Its discovery predates recorded history, and its fast-moving nature across the sky led to its naming after the swift messenger of the gods in both Greek and Roman mythology, Hermes and Mercury respectively. This celestial body, renowned for its speed, symbolized the divine intermediary, a fitting metaphor for a planet that seems to bridge various cosmic phenomena. Over the centuries, astronomers have dedicated themselves to peeling back the layers of mystery that cloak this enigmatic planet. With each discovery, we've gained deeper insights into Mercury's unique properties and behaviors, continuously expanding our understanding of one of the solar system's most intriguing worlds. In the early 17th century, Johannes Kepler revolutionized our understanding of Mercury with a significant discovery. He observed that Mercury's orbit around the Sun was not circular, as previously thought, but irregular, an elliptical path that challenged the prevailing assumptions of the time. This finding set the stage for centuries of advanced study, leveraging evolving tools and methodologies to unravel the planet's mysteries. Over the 19th and 20th centuries, enhanced telescopic technology and new scientific approaches brought to light more crucial details about Mercury. To date, 2 missions have successfully reached this swift-moving planet, with a third, Bepi Colombo, a joint venture of the Japanese and European space agencies, set to arrive in late 2025. While ground-based studies and direct explorations have been limited, they have been instrumental in overturning many misconceptions about Mercury's nature. Despite its modest size, with a diameter just slightly larger than Earth's moon, Mercury is over 4 times as massive. This reveals its surprising density. Mercury is the second densest planet in our solar system, trailing only Earth. This remarkable density stems largely from its oversized iron core, which constitutes about 60% of its total volume compared to Earth's core, which makes up about 17%. This unusual internal structure has fueled a variety of theories regarding Mercury's formation and geological history, suggesting that there is much more to this small planet than meets the eye. Scientists theorize that in its formative years, Mercury's outer layers might have been stripped away by intense solar winds or a colossal celestial impact. This hypothetical collision likely wasn't a direct strike, but rather a glancing blow, which could explain why traces of Mercury's original crust and mantle are still detectable today. This scenario suggests a dramatic birth for the planet, with its rugged, iron-rich core laid bare while preserving fragments of its initial geological layers. This theory gained some credence with the findings of Mariner 10, the first mission to Mercury, which launched in 1973. Among its many discoveries, the revelation that Mercury retains a magnetic field was particularly surprising. Scientists had expected that a planet of Mercury's modest size would have cooled rapidly, its interior solidifying and thereby extinguishing any planetary magnetism. Yet, the existence of a magnetosphere suggests that beneath its scarred surface, part of Mercury's core remains dynamic, still generating magnetic fields, albeit weak ones. Mercury's magnetic field is about 100 times weaker than Earth's at their respective surfaces, indicating a sluggish dynamo at work. This finding implies that Mercury is in the twilight of its geological evolution, nearing the end of its active life, much like Mars is considered today. In the 2010s, the second mission to Mercury provided further insights, continuing to unravel the complex life story of this enigmatic planet. The Messenger mission unveiled a curious anomaly about Mercury. Its magnetic field is distinctly off-center. The magnetic South Pole does not align with the geographic South Pole. Rather, it is skewed, located near the planet's equatorial region. This unusual positioning offers unique insights into the internal dynamics of Mercury, suggesting a complex geological past and a slowly decelerating core. Antonio Genova, an aerospace engineer and student of planetary geodesy and geophysics at Rome's Sapienza University, emphasized that understanding the magnetic field is like peering into the planet's heart, revealing secrets of its ancient history. To explore these mysteries further, Genova and his team are eagerly anticipating data from the ongoing Bepi Colombo mission, hoping it will shed light on aspects of Mercury that remain obscured. On another note, Mercury's atmosphere, or lack thereof, presents its own set of puzzles. What Mercury has is so sparse that scientists refer to it not as an atmosphere, but as an exosphere, a thin veil of gases barely exerting any pressure. This exosphere is continuously assaulted by solar radiation, requiring constant replenishment from the planet's surface. Since the 1980s, astronomers have detected emissions from atomic sodium, potassium, and calcium within Mercury's exosphere. These metals emit strong signals that can even be observed from Earth, offering a spectral snapshot of Mercury's volatile surface interactions with solar winds. Using telescopes from various observatories, scientists have been able to detect metallic particles, not gases, in Mercury's atmosphere. These metals, including sodium, potassium, and calcium, do not originate as atmospheric components, but are instead delivered by solar particles and meteorites crashing into the planet. These impacts contribute to a spectacular phenomenon, a radiant tail stretching 15 million miles behind Mercury. This tail, composed of gases and particles from the Sun interacting in the exosphere, changes length as Mercury orbits closer to or farther from the Sun. At certain times of the year, if one were standing on Mercury, this tail would manifest as a faint orange glow in the sky, reminiscent of sodium vapor streetlights, casting an eerie luminescence over the alien landscape. Surprisingly, this planet, which perches perilously close to the Sun's searing embrace, harbors not just metals, but potentially water ice. In the 1990s, radar signals sent from the Arecibo Observatory in Puerto Rico and the Goldstone facility in California revealed highly reflective areas near Mercury's poles, likely ice deposits. This discovery was unexpected and intriguing, given Mercury's close proximity to the Sun. Could Mercury's nearness to the Sun paradoxically contribute to the formation of ice? Recent investigations into the chemistry of Earth's surface have entertained the notion that intense heat might paradoxically promote ice formation under specific conditions. This startling hypothesis suggests that even in the solar system's furnace, Mercury might coolly harbor hidden reserves of ice, challenging our understanding of where and how water can exist in our solar system. Ice on Mercury, despite its proximity to the sun and surface temperatures reaching up to 750 degrees F during the day, can indeed exist in permanently shadowed craters. Here, temperatures plummet to around 330 degrees F, cold enough to maintain ice, particularly as these areas are insulated from solar heat. Insights from the now-defunct Messenger mission, which relayed data for over a decade, confirmed the presence of ice. The chemical processes by which some of this ice formed, however, are still being deciphered. Recent research has shed light on how water molecules could accumulate on Mercury's surface even amidst such extreme temperatures. This idea, while seemingly counterintuitive, isn't entirely new. The underlying chemical mechanism has been well documented in numerous studies since the late 1960s. However, applying these principles to the irregular and mineral-rich surfaces of a planet like Mercury marks a pioneering stride in planetary science. The surface minerals on Mercury, rich in hydroxy groups, combinations of oxygen and hydrogen atoms, play a crucial role. Due to the planet's weak magnetic field, which cannot adequately shield it from the solar wind, a stream of charged particles, including protons, bombards the planet. These positively charged subatomic particles have been shown in the new study to traverse the planet's surface, influenced by its magnetic anomalies. This interaction might facilitate the formation of water molecules, suggesting a dynamic and ongoing transformation of Mercury's seemingly barren landscape. When the sun's intense heat energizes hydroxy groups on Mercury's surface, these molecules become a bustling arena of chemical activity. Protons, implanted in the soil by the relentless solar wind, collide with these groups, catalyzing reactions that produce water, made up of hydrogen and oxygen. However, not all created water molecules meet the same fate. While some decompose back into their elemental forms under the harsh sunlight, others sink back into the surface or even escape into space. Yet some water molecules escape these harsh outcomes altogether. These survivors make their way to the poles of Mercury, finding refuge in the permanently shadowed craters. Here, insulated from the solar furnace, these molecules can settle and accumulate as ice. This process, seemingly minor in isolation, is projected to have profound implications over geological timescales. According to models, Mercury could amass approximately 11 trillion tons of water ice over the next 3 million years, accounting for about 10% of the planet's observed ice. The remaining ice likely originates from external sources such as comets, asteroids, and meteorites. This surprising development highlights that Mercury is not an isolated case in the solar system. Water ice has been detected on other celestial bodies, illustrating a more complex and interconnected cosmic ecosystem than previously thought. Water ice isn't unique to Mercury. It has also been found on the Moon, asteroids, and comets. However, the rate at which water accumulates on these bodies varies. For instance, the Moon lacks sufficient heat to drive the same chemical processes active on Mercury. Earth and other terrestrial planets have their water dispersed globally by natural phenomena like weather cycles. For scientists seeking ancient ice in its most pristine form, Mercury's poles may offer the best samples in the solar system. Mercury surprised scientists once more when Messenger detected a variety of volatile substances on this sun-scorched world. Volatiles, which are chemicals that can quickly transition from solid to gas, include not just water, but also sulfur, potassium, and chlorine, elements that typically evaporate at high temperatures. These volatiles are distributed across Mercury's surface, indicating a dynamic and complex geological history. Despite its small size, Mercury contains as much volatile matter as other cooler terrestrial planets in our solar system. This unexpected finding suggests that Mercury's formation and evolution may share more similarities with its planetary neighbors than previously thought. There is ongoing scientific debate over the origins and retention mechanisms of volatiles on Mercury. Some scientists propose that these volatiles may have recently emerged from beneath the surface, while others believe they have been present since Mercury's formation, condensed from its protoplanetary disk. These discoveries prompt intriguing questions. If planets close to their stars retain volatiles, especially water, could these regions also be habitable? Recent findings suggest that salty glaciers in craters near Mercury's north pole might provide an ideal environment for unusual life forms. This discovery has led planetary scientists to wonder if Mercury, our solar system's closest planet to the Sun, might support some form of life. The existence of these salty glaciers adds to the growing evidence of nitrogen glaciers on Pluto, indicating that such phenomena may be widespread across the solar system, from its hottest to its coldest regions. Unlike the familiar icebergs on Earth, the glaciers found in Mercury's Rachmaninoff and Eminescu craters are unique. These are not ordinary ice formations, but rather salt flows that have blanketed Mercury's surface and trapped volatile substances beneath. This fascinating revelation opens new avenues for understanding planetary formation and the potential for life in the most unexpected places. Asteroid impacts have revealed the peculiar saltbergs in Mercury's craters by dislodging material that had been locked beneath the surface. Given that Mercury is 2.5 times closer to the Sun than Earth, the discovery of glaciers on this planet is astonishing. Despite the intense heat at such close proximity to the Sun, these salt flows have managed to preserve their volatile contents for over 1 billion years. Geologists have a good understanding of salty habitats on Earth and their potential for supporting life. Mercury's salty deposits, although different from ordinary icebergs or Arctic glaciers, bear a resemblance to the conditions found in some of Earth's most inhospitable places, such as the Atacama Desert in Chile. Certain salt compounds can create livable niches, prompting the question, could Mercury have any habitable regions beneath its surface? Considering this possibility, the idea of subterranean life on Mercury becomes intriguing. Protected from the Sun's harsh rays, such life could exist within the planet's underground volatiles, including water. Just as planetary systems have Goldilocks zones, regions where liquid water might persist, researchers hypothesize that Mercury could have a potentially habitable region underground. This concept opens up new frontiers in the search for life in the solar system, suggesting that even the most unlikely places might harbor life. Beneath the surface of Mercury, the potential for habitable conditions could elevate interest in exoplanets with similar characteristics, influencing the search for extraterrestrial life. The discovery of these glaciers has also shed light on a long-standing mystery concerning Mercury's craters, which often appear with missing sections. Researchers now believe that these depressions were once filled with volatile substances that were released into the atmosphere upon impact, only to dissipate afterward. Understanding how these unstable layers formed in the first place remains a significant question. Evidence from Mercury's north pole suggests that a fully developed terrain served as the depository for these volatiles. Scientists propose that these materials may have originated from the early collapse of Mercury's hot primordial atmosphere. Another intriguing theory, put forth by Jeffrey Cargill, posits that early Mercury might have harbored lakes. He suggests that Mercury's volcanic core once released dense, extremely salty steam that later condensed, leaving behind salt deposits. To fully understand what lies beneath Mercury's surface, further studies are essential. Moreover, Mercury's landscape is dotted with irregular depressions that raise additional questions. These geological features hint at a dynamic history, potentially involving processes that could also inform our understanding of other planetary bodies. The discovery of Mercury's unique glacial formations and volatile deposits not only challenges our assumptions about this small, sun-scorched planet, but also opens up exciting possibilities for the existence of life in unexpected places throughout the universe. These intriguing formations, known as hollows, were first glimpsed by Mariner 10 in 1975 and later photographed in high resolution by the Messenger mission. Ranging from a few dozen feet to over a mile across and up to 120 feet deep, these depressions resemble the soft, airy insides of a sourdough loaf when cut open. Welcome to Blasovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blasovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe. Live Q&A sessions with experts. Your membership will grant you the chance to participate in live Q&A sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos, and join us in unraveling the secrets of the universe. Become a Blasovia Science TV member today, and together, we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comments.